Hi friends, welcome to our channel. Let's have a look at problem 3708, longest Fibonacci subarray. In this video, we're going to practice dynamic programming, right? So here we are given an array of positive integers called nums. So a Fibonacci array is a contiguous sequence whose third and subsequent terms each equal to the sum of the two preceding terms. So we want to return the length of the longest Fibonacci subarray in nums. So here is an interesting note, which says that subarrays of length 1 or 2 are always Fibonacci. So here, the Fibonacci is in the sense of this current problem, right? So in the current problem, like this one, 52796 itself is a Fibonacci array, right? But in mathematical sense, the Fibonacci array is this, is defined as like Fibonacci 0 is say 1, and the Fibonacci 1 is 1, and then this n equals f n minus 1 plus f n minus 2. So this actually determines that the Fibonacci sequence is strictly is increasing at least, right? But here, you know, this in the sense of the current problem. So this problem in example 2, the output is 5 because the nums list itself is a Fibonacci array in the sense of the current problem, right? It's different from the mathematical sense. So this is just some side remark. So you can quote this out. So for this kind of problem, it's rather straightforward. Basically, we can use a DP, right? So the DPI will be the longest, or the length of the longest Fibonacci subarray ending at index I, right? And then the return will be the max and DPI, right? For I, so in between 0 and n minus 1, where n is the length of this nums list. So with that said, let's do this practice. It's rather straightforward. First, I'm going to have a length of this n. Retrieve this attribute of the list object. So this brings us some convenience. So we can initialize DP as list. And the reason I'm going to use this is that subarrays of length 1 or 2 are always Fibonacci. So this way we just need to set DP 0, so to be a 1, right? Then all the others should at least 2. That will be the initialization. So now we are going to iterate. So we can iterate from index 2. So for I in range 2 to the end. So in other words, ending at n minus 1. So then the condition will be the following, rather straightforward. If nums I equals nums I minus 1 plus nums I minus 2. So in this regard, so DPI can be extended 1 more than DPI minus 1. So therefore, it's DPI minus 1 plus 1, right? So now we just need to return the max of this DP. So you can do a test here. Let me see if where I make it wrong. Let's see. DP, this 2 and this 1. If nums I equals, so DP, not increment, so this equals. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So if you don't want to, finally call this max function, you can do something like this. The result will be DP1, right? So so let's see, it's the DP2, because the length here is at least 3, right? Therefore, this result will be at least 2. And then what we are going to do, once we set this, so we're going to call this max DPI and the result variable. And then you just need to return the result variable. In other words, we do the comparison in between the for loop. So you can submit that. So it's also fast, right? So with that said, I guess that's the coding part for this problem. So here again, we are practicing dynamic programming, but this one is rather straightforward logic in terms of using dynamic programming. So with that said, I guess that's it for the current video. Thank you for watching.